Hello everyone. Today we will discuss about the refraction of light. Though we have studied its basic concepts in class 10th, let's just recap that. So what is refraction of light? See, whenever a light falls on a transparent interface, a part of it is reflected and a part is refracted. That means if this is the interface of the transparent medium, and the light is incident here, then a part of it is reflected and a part is refracted. So what is happening here is this ray of light which is incident here is reflected back to the same medium and a part of it is transmitted to the other medium. Now we can mark the angles. If this is your angle of incidence, we know by laws of reflection that reflected angle will also be same, but when it is refracted, then this is angle of refraction. Now if it is denser medium, then this light ray bends towards the normal, right? So this is what happens when a light ray strikes a transparent medium. So this is your transparent medium. In the present video, we are concerned about the refraction of light. So refraction of light is nothing but the bending of light ray when it moves from one medium to the other medium. You have also studied about the laws of refraction in lower classes. So who gave the laws of refraction? These were given by Snell. He's a scientist. So the first law is, these laws are given on the basis of the experiment which he conducted. So for the first law is the incident ray refracted ray and normal to the refracting surface at the point of incidence. Lie in the same plane. Second law is the ratio of sine of angle of incidence to the sine of angle of refraction is constant for a given pair of media. This ratio is called as refractive index. Right? So we draw a diagram for refraction by a glass slab. This is the normal on the first face. This is the incident ray. It would have gone in this direction if there would have been no change of medium. So that's why I have drawn this with a dashed line. But since there is a change in the medium, so what will happen that it bends towards the normal if this is the denser medium. If this is the rarer, then it will bend towards the normal. So this is moving this way, and this angle is angle of refraction at first phase. This is I1 suppose. And when it moves from denser to rarer medium again, what happens is that if this is the normal at the second phase, now it is moving from denser to rarer medium. So it will bend away from normal. And this angle is the angle of emergence, which I am denoting here by I2. This is the angle of incidence for the second interface. If I consider this as first interface and this as second interface, I can say that at first interface, that is rarer to denser, right? What happens is that the light ray bends towards normal, as we can see with the arrow, right? And at the first interface, I1 is equal to angle of incidence and R1 is equal to angle of refraction, right? So if we are finding the refractive index, we are representing refractive index by n, right? So if we are writing n to 1, so this is the second medium, this is the first medium, right? So n to 1 means refractive index of medium 2 with respect to medium 1, right? So this, according to second law of refraction, refractive index of second medium with respect to 1 is equal to sine of angle of incidence to the sine of angle of refraction, right? Here what is important is that the angle in the opposite medium is considered sine of is considered as angle of incidence. Angle in opposite medium is angle of incidence, right? That means if we are finding the refractive index of this medium, then this opposite angles and opposite medium angle is considered as angle of incidence. Now if I want to write this n21 at phase 2, that means refractive index of this medium with respect to this all medium, this is also first medium obviously when this is coming back to the same medium. So from this interface also we can write the angle of this refractive index. So we can write down just at second interface, right? At second interface, if we are moving from denser to rarer, right? So that means medium 2 to 1. Then the first thing is that ray bends away from normal. This is the arrow, it is bending away from normal. Right? And R2 is angle of incidence for second surface, right? And I2 is angle of refraction for second surface, right? And it is also clear that here R1 is equal to R2, that is alternate angles in mathematics. So it can be proved that I1 is equal to I2. Technically, if we take this whole figure, then I1 is angle of incidence, I2 is angle of emergence. So you can say angle of incidence is equal to angle of emergence. Now what is the reason for this refraction of light? Here the light ray is moving from one medium to the other, then the bending is happening. So why this bending is happening? The reason is that the speed of light in different media is different. So if it is in rarer medium, then the speed is more. If it is in denser medium, then the speed is less. So that's why the bending occurs. Reason for refraction: the speed of light is different in different media. So we can just mention in rarer it is more and in denser it is less. That's why the light ray bends. So actually this light ray is representing a beam of light. So for simplicity we are just drawing a single light ray, right? So this was about the basic phenomena of refraction and the laws of refraction. And now we can understand, if we are given this N21 we have calculated from the refraction at the first phase. So this is first equation. Now we can also write N21 at second phase. So N21, how will you write N21 at second phase? So N21 means we have to find the refractive index of the second medium. I told you that the angle of the opposite medium is taken as angle of incidence. So for the second phase, we are finding the refractive index of the second medium with respect to 1. So for second phase, I2 will be taken in the numerator because I2 is the opposite medium of the medium whose refractive index we are writing. So for the second phase, N21 will be sine of I2 upon sine of R2. Also, if I want to write refractive index of medium 1 with respect to 2 from phase 1, suppose, and 1, 2. We have to find the refractive index of this medium. So the angle in the opposite medium will be taken in the numerator. So this is N1, 2. So second medium angle is R1. So this will be sine R1 upon sine, in the same medium, what is the angle? I1, right? So from this is your first equation. This is your second equation. From equation 1 and 2, what can you say about the relation between N21 and N12? N21 is equal to 1 upon N12, since here sine I1 upon sine R1 is equal to 1 upon N12, right? So this is an important result. Second, now we can discuss some formulas for refractive index. So one formula we have already written, it is the ratio of the sine of angle of incidence to sine of angle of refraction. Second thing is, it is defined as the ratio of speed of light in air to speed of light in in that medium. Whose refractive index we are talking about. So that means if we are talking about the refractive index of second medium with respect to 1, then we can write it as speed in first medium and upon speed in second medium. Also, if we are saying that refractive index of a medium with respect to air, then we will write speed of light in air upon speed of light in that medium, right? Right. Also, this refractive index can also be written as, we are taking this as general formula, right? So this we can write like this also. You have studied this in 10th also. So here what is important is that you have to remember that this is, if we are finding the refractive index of second medium, then opposite medium wavelength in numerator, right? This is the trick actually to learn. Similarly, here also we know that this is opposite medium velocity in numerator. Right? So this was about the trick, and this is the formula for the refractive index. One more thing, that the frequency does not change, frequency of light does not change when it passes from one medium to the other. So this was all about the refractive index. Now we can discuss a few more important points. For that I need to rub the board. A very important concept, that concept is optical density. Very important. Optical density and mass density are two different things. Are different. So what is optical density? I can write it. Optical density is a ratio of the speed of light in the media. Right? But mass density, as you all know, that mass density is mass per unit volume. Optical density depends on the refractive index, or you can say optical density is directly proportional to the refractive index. right? So an optically denser medium may be less denser in terms of mass density. For example, turpentine is turpentine and water case. If we talk about optical density, then it's optically more denser than water, right? So these are not the same things. More is the optical density, more is the bending. More refractive index means more optical density, means more bending. So these were a few important points. Now we can take the case of composite slab also here. So for the composite slab, we can take a case of medium 1, medium 2, medium 3. So the outer medium is medium 1, then we are taking another medium, and then we are taking the third medium. So this is your medium 1, this is medium 2, and this is third medium, right? So in such cases, we can prove a relation. This is the normal. We can take this incident ray which bends towards the normal when it passes through the first interface. This is the first interface, this is the second interface, and this is the third interface. So at first interface, when the incident ray is incident, this is angle of incidence I1. It bends towards this, that means medium 3 is denser than second medium is denser than first medium. So in that case, successive bending will be there. So here also at second phase, this is the normal. At first interface, R1 is the angle of refraction. At second interface, R2 is the angle of incidence, and then when it comes here, it again bends. That means now this is I2, which is the angle of refraction for second interface. R2 is the angle of incidence for second phase. Now when it is incident here on the third phase, now it is moving from the denser medium to the rarer medium, so it will bend away from the normal now, and it will bend away means it will be parallel to the initial direction of the incident ray. If you look at this, this is the direction of the incident ray, initial incident ray. right? And this shifting in the initial incident ray and the emergent ray, this is called as lateral shift, right? And this angle at which it emerges, we are writing it I3 if this angle of incidence for the third phase is R3. I hope this is clearly visible. So for first interface, angle of incidence is I1, angle of refraction is R1. Second interface, angle of incidence is R2, angle of refraction is I2. And for third interface, angle of incidence is R3 and angle of refraction is I3. So if we want to find a relation for the composite slabs, we can prove a relation N13 is equal to N12 into N23. This can also be written as, you already know this way of writing, right? So this is what we have to prove. Now look at this diagram. We know that in this diagram, R1 is equal to R2. These are alternate angles. And I2 is equal to R3. These are all also alternate angles. And also angle of incidence is equal to angle of emergence. So if I write the formula for N12, this will be refractive index of first medium with respect to second medium. So look at this first medium with respect to second. Which angle should I write in the numerator? R1. So I will write down sine R1 upon sine I1. Similarly, if I want to write n of 2 with respect to third, so refractive index of second with respect to third. So third medium is opposite. For second, third medium, refractive index of second with respect to third. So I3, I2 will be written in numerator upon sine R2. Now if I combine these, this I am marking as equation 1 and this as 2, the complete as 2. This as 2 and this as 3. So 2 multiplied by 3. What will I get? N12 into N23 is equal to sine R1 upon sine I1 into sine I2 upon sine R2. Now R1 is equal to R2. So this will be cancelled. So I can write here, since R1 is equal to R2. Now I2 is equal to R3 and I1 is equal to I3. So this can be written as sine I2 is equal to R3. So this will be sine R3 upon sine I3. Why so? Since I1 is equal to I3 and I2 is equal to R3. And what is this? This is actually N1 3, right? Because if we are writing N1 3, that means it will be sign of opposite medium. So for fun we are writing for this interface, the opposite medium is R3. So sign R3 will be in numerator, sign I3 will be in the denominator. So this is hence proved. What does it mean? It means if we have three mediums, so it works as if only first and third medium is there, right? So between layers are generally considered to be absent. So this is all about the basic concept of refraction. Hope you understood it. That's all for now. Have a nice day.